Hi everyone, this is Mrs. Torigno and this is page 3 of the Chapter 7 test review. This video will cover questions 13 through 17. Okay, question number 13 is more equation solving. Now luckily we don't have anything else over here with the x that we need to bother getting rid of. All we have to worry about is this exponent, and my exponent is negative 4/5. So I'm going to raise that to the power of the reciprocal, which would be 5/4. Keep in mind though that because this is negative, my reciprocal also needs to be negative to get those to cancel out. So I'll end up with the power of negative 5/4. Whoops. And that means I'm doing 16 to the power of negative 5/4. So in my calculator, I'm going to type in 16 to the power, and then in parentheses, negative 5 divided by 4. Notice I get this decimal, 0.03125. I don't expect you to know what fraction that is off the top of your head, but do notice that the question says my answer needs to be in a whole number or a simple fraction form, so this decimal is not okay. Now some of you might know how in a calculator to go in and change that to a fraction, but I'm going to show you an easier way. The reason this came out to be a decimal is because I typed in this negative exponent. So just like many other problems, I'm going to ignore that negative for now. I'm going to raise to the power of just 5/4, and I end up with 32. So now that I know that answer is 32, think about what that negative exponent would do. Okay, that negative exponent is going to take that 32 and flip it over. So it means my answer will be 1/32. And just to make sure I'm right, let's type in 1 divided by 32. You see that decimal, 0.03125 again? So this decimal is the decimal representation of 1/32, which is the answer that I'm looking for. Okay, so my suggestion to you is go ahead and try typing it in with the negative exponent. If you're having a hard time deciding when you should and when you shouldn't, just give it a try. But if it comes out to be a decimal, go back and try it again without the negative and see if you can then just take it and flip it over. Okay. Question 14 is really asking you to pull together a lot of information. This is asking you to take these functions or these values and put them in order from smallest to largest. So we have x squared, we have x to the 1/2, we have x to the negative 2, and then we have just x. So I'm going to kind of put x in the middle and compare everything to x. Just regular value of x. So let's start with x squared. Do we think x squared would be larger than x or smaller than x when x is a number bigger than 1? I would just think of a whole number. If you need to, pick a number. Let's say x is 5. Is 5 squared bigger than 5? Yeah, it sure is. Okay, if x was 10, is 10 squared bigger than 10? Yep, it sure is. So I know that x squared is going to go over here someplace. I'm leaving some space there because I don't know if there will be anything in between here, and I don't know if there will be anything over on this side. So I'm kind of just sorting everything out right now, and then I'll write it a little more cohesively. All right, let's look at x to the 1/2. X to the 1/2 is like the square root of x. So if x is a number bigger than 1 and you take a square root of it, is that going to be bigger or smaller than x? Well, you should find that that would be smaller. If x was equal to 4, the square root of it would be 2. So I know x to the 1/2 goes over here someplace. Okay. Now x to the negative 2, I'm going to rewrite that for a second. X to the negative 2 is really 1/x squared. Okay. So let's think of 4 again. If I do 4, then this is 1/4 squared, which is 1/16. Let's see how tiny that is. 1/16 is 0.0625. Oops, I'm sorry, I don't know if you can see that. 0.0625. So that's way smaller than the x I started with, which was 4. So I know it's going to be over here someplace. The only thing I don't know is which one of these two is going to be bigger. Okay, I know these are my last two, but I don't know which order these go in. So again, thinking back to that example, if I do 4 to the power of 1/2, that's like the square root of 4, which is 2. If I do x to the power of -2, that's going to give me this. Is this bigger or smaller than 2? Hopefully you see that it's smaller, and so this really needs to go down here on this side. So just to write this out a little cleaner, it should be x to the -2, x to the 1/2, x, and x squared. And also notice that really all that's happening here is these exponents are going in order. You've got -2, then you've got 1/2, then you've got 1, then you've got 2. So really all you did was arrange these in order of exponents from smallest to largest. So that might make sense to you too. But if you're stuck on a problem like this one, I would really recommend that you pick a number that's pretty easy to work with, like I did 4. I think I used 5 or 10 for a couple of them too. Pick a number that's easy to work with and start plugging it in and just see what you get. Okay, let's take a look at question 15. It says 3 to the 6th equals the quantity 3p cubed. So I'm going to start over here on the left where it gives me 3 to the 6th power. And before I can move any further, I need to know what 3 to the 6th power is. That is 729. Now over here on the right, I'm going to simplify anything that I can. And remember, this 3 out here means I'm going to raise this 3 to the power of 3 and the p to the power of 3. So 3 to the power of 3 is 27, and p to the power of 3 I'm just going to write like that. So all I did right now was simplify the left side and the right side. Now if I'm going to solve this, I need to get rid of this 27. I'm trying to find out what p equals. So let's do 729 divided by 27, and it actually comes out to equal 27. That's just coincidence, by the way. So I end up with 27 is equal to p cubed. And then I need to get rid of that power of 3. Remember, anytime you're looking to get rid of a power, I'm going to raise to the power of the reciprocal, which in this case is 1/3. So if you need to in your calculator, you can type in 27 to the 1/3 power. Probably many of you are to the point now where you recognize that power. 27 to the 1/3 is just equal to 3. So your final answer is just 3. Okay, let's take a look at number 16. Number 16, you're going to be tempted to actually work out 4 to the 8th and 5 to the -8th and get a big scary decimal for that one, which you could do. Okay, you could work with this problem by actually figuring out 4 to the 8th and 5 to the -8th. And that's really what we did back here in question number 15, so I wouldn't fault you for that at all. But I do want to show you a trick for this one that makes this one a lot easier. Notice that this 5 to the -8th, that's a negative exponent. So that means that really needs to go down below this 4 to the 8th. It needs to go on the bottom. So I'm going to rewrite this as 4 to the 8th over 5 to the 8th equals z to the 8th. And I'm going to leave this alone for now, okay, because I'm seeing some really nice patterns here that all these exponents are the same. I don't want to get rid of those. Now let's get rid of that power of 8 by raising to the power of 1/8. Okay. If you wanted to actually type this into your calculator and work it out, you could, but I want you to notice that here, when you raise a power of 8 to the 1/8, it cancels out. It's going to do the exact same thing here and the exact same thing here. So this 8 will cancel, this 8 will cancel, and you'll be left with just 4 over 5. Okay, so that one's a little bit tricky. You could take it the long way. You could actually evaluate these powers and work with a really large number and then break it back down, but I just wanted you to notice that there were some patterns in that one that might help it go a little bit more quickly. Okay, question 17. We've done this one as warm-ups a couple of times in class so far. It says the point -2, -32 is on the graph of a power function, and it wants to know, is this function even or odd? Well, notice that you're putting in a negative number and you're getting a negative number out. The only way that can happen is with an odd power, because remember, if you had an even power, it would turn a negative number into a positive one. So this is definitely an odd power function. Now it wants us to write an equation, which means my job is to figure out what that power actually is. I need to know -2 to what power gives me -32. And I know that it's going to be an odd number. So let's do some guess and checking. Okay. I know it's not -2 to the first power, because that would just be -2. So I might try -2, remembering to put that -2 in parentheses, to the power of 3. Again, I'm only checking odd powers. That comes out to be -8, so that's not it. Let's try -2 to the power of 5. And there you go. -2 to the power of 5 gives you -32. Now that's not your equation though. Your equation for a function has to include a y and an x. So instead of this, I'm going to write y equals x to the power of 5. And that would be your equation of your function. This is a mistake I see a lot. This just helps you figure out what the power is, but then you need to write it as a function with a y and an x. And my last question, give the coordinates of 4 other points that lie on this line. We talked about 2 points in class that will lie on the line of every single power function. And those 2 coordinates are 0, 0, and 1, 1. That's because 0 to any power is 0, and 1 to any power is 1. So now I just need to come up with 2 more. To pick my other 2, I'm just going to pick anything I want for x and raise it to the power of 5. So maybe I'll try 3. 3 to the power of 5 is 243. So I would write 3, because that's what I put in for x, and then 243, because that's what I got out for y. And then maybe I'll try 4. So 4 to the power of 5 gives me 1024. So I would say 4, 1024. There are lots of different answers because you could pick anything you wanted for x and plug it in and then turn it into a coordinate. But that 0, 0, and 1, 1, those are really easy answers to come up with. So save yourself some work and start with those 2, and then just work to find the other 2. Okay, that does it for this video. We've got one left to go for the last page.